you have the word extrema or extrema. I call it extrema. Some people call it extrema. On an interval, a closed or open interval. Okay, you have something called an absolute extrema, a relative extrema. Okay, and within that you have things called critical numbers or critical points. Three major concepts here. Absolute extrema, when you have an interval or a function, they are the highest and lowest point on an interval, and it can include the endpoints. Okay, absolute means it's the highest and lowest point on a graph, including the endpoints on an interval. Let's say we have this graph. Okay, and let's say my interval is from here to here. There's my interval. Now, the absolute extrema is the highest or lowest point on that interval, including the endpoints or possibility of being them. So you look at the graph, or you look at a table, depending on what you have, and you have to find the highest or lowest point. So looking at this, can you tell the highest or the absolute max is right here? That's your absolute max. Can you also tell your minimum, your absolute minimum is right there? Now, if you change the interval, would your absolute maxes and mins change? Yeah, it all depends on your interval. Okay. Now, relative extrema are critical numbers which are a hill or valley. Now, we first have to talk about critical numbers if you want to talk about relatives. So, looking at this, critical numbers. What a critical number is, they're critical. Numbers. Hint the name. They're very important numbers in calculus. Very critical numbers. What you do is you take the derivative, and you want to find C, a value, where the derivative equals 0. So basically where the slope is 0. Or where the derivative does not exist. And the output has to exist. Meaning you can't have a critical number if there's nothing there. Got it? The point has to exist to have a critical number. If there's nothing there, you have a critical nothingness. So, you have the derivative is 0, or the derivative does not exist. Now, where the derivative equals 0, look at this graph. Do you understand the maxes and mins right now are the critical numbers? Do you see the derivatives equal 0? Now, what does a derivative does not exist look like? Where the derivative does not exist are asymptotes, which actually, does the value exist there? Okay, we'll talk about that. You have the, where else does the derivative not exist? You have asymptotes, you have slopes straight up and down. Got it? Vertical lines. You have, where else does the slope not exist? Points, jagged points. All of those are places where your derivative does not exist. So and then, if you think about it, okay, those are where your derivative does not exist. All those are critical points, important points that we want to start talking about, and that's what 3.1 talks about. Now, going back to relative extrema, they are critical numbers that are hills and valleys. So in this situation, these two values are also relative extrema. They're your maxes and mins. They're your hills and valleys. Okay? Relative extrema are just hills and valleys. Absolute mins and maxes are hills and valleys, but also endpoints. There's a difference. Absolute says count the endpoints. Relative basically says don't count the endpoints, just talk about your hills and valleys. There's a difference between the relative and absolute. Absolute means count the edges. Meaning, what do I mean by count the edges? If we made another graph here, okay, let's say we made it from here to here. Well, now you have several points. Well, what's on this interval, what's your relative max or min on this one? On the interval? That's your relative max or min, correct? But what's your absolute max or min? Well, your absolute, this is your absolute max right here. But your absolute min, wouldn't it be this point, the end point? Does this interval have any relative mins? No, because there's no point where it's a valley. Relative mins are valleys, and in the interval we didn't have any valleys. So relative maxes and mins are hills and valleys. Absolute maxes and mins are hills and valleys plus endpoints.